Hello everyone, this is Vasant, a 9-pointer at IIT Bombay from the Department of Civil Engineering. In this video, we are going to discuss about stress strain diagrams. Why this topic, stress strain diagram, is important. It provides design engineers with important parameters needed for application in design. This means while designing a structure, what parameters should you need to consider? That will be given by this stress strain diagram. It gives many mechanical properties. Mechanical properties such as modulus of elasticity, toughness, strength, many more things. It also helps in fabrication and it helps us to understand how a given material deforms with increasing loads. Means when you increase the load gradually, how the deformation will occur in a member. That will be given by this stress strain diagram. So before understanding stress strain diagram, we need to understand some certain concepts. So first one is Hooke's law. What Hooke's law says? Hooke's law says up to certain limit of stress and strain, stress will be directly proportional to strain. That is sigma directly proportional to epsilon. That means sigma is equals to E into epsilon, where E is modulus of elasticity, which is also known as Young's modulus. So E will be is equals to sigma by epsilon. So this will be a straight line. If you draw stress strain curve, it will be a straight line, right? So this is about Hooke's law. We already studied Hooke's law. So this is linearly elastic material. Linear elastic material. So now maximum shear and tensile stress planes in tension. Means when you apply tensile load on a member, there will be expansion, we know that. And in the normal plane, in the principal plane, there will be only tensile stress, there will be no shear stress, because for that cross section, the load will be perpendicular to the cross section, right? So there will be only tensile stress, shear stress will be zero. But if you take inclined cross section, then there will be tensile stress and shear stress developed on that cross section, because for that cross section there will be two forces, one is along the cross section and another is perpendicular to the cross section. So there will be two stresses, tensile stress and shear stress. So if we take a certain plane like this, at a certain angle the shear stress will be maximum, and for certain angle the tensile stress will be maximum. So for a angle theta, we get sigma theta will be is equals to sigma x into cos square theta, right? And for angle theta, tau theta will be is equals to sigma x sin 2 theta divided by 2. So what is the maximum stress, maximum tensile stress? So sigma max will be is equals to sigma x when theta is equals to 0 degrees, right? And this will be is equals to tau theta will be is equals to max sigma x by 2 when sin 2 theta will be is equals to 0. That means theta will be is equals to 45 degrees, right? So means this is maximum shear. So maximum shear plane will be at theta is equals to 45 degrees, and maximum normal stress plane will be for theta is equals to 0 degrees, right? So this is 0 degrees case. So here the angle which we need to consider is this one. Okay. So if you consider a cross section like this, then the angle will be between this longitudinal axis and this longitudinal axis. Okay. So this is theta is equals to 0 plane. For this there will be only sigma x, because if you apply theta is equals to 0 in this, we will get tau theta is equals to 0 will be 0, right? This is 45-degree plane, because if you consider longitudinal axis like this, perpendicular axis like this, so angle between these two is 45. Okay. For this we have tau theta is equals to sigma x by 2, and sigma theta is equals to 45 will be also is equals to sigma x by 2. So there will be tensile stress sigma x by 2 on 4 sides. Similarly, there will be sigma x by 2 tau max shear stress along the cross sections. Okay, this is about maximum shear and tensile stress planes. Now, what is grain boundaries? This is one of the important concepts. So see, how do you prepare the material? Means how do you prepare steel? How do you prepare aluminium? First, what you do? First, you extract the ore, right? So first you extract the metal, means extract ore. Extract the ore. From that we will separate the metal. From that we will liquefy the metal. Next step will be liquefaction of the metal. Then from liquefaction we will remove the impurities present in the metal. Then we will solidify, and then we will get required material or required metal. Okay, but you are removing the impurities in the process of liquefaction, but there will be some small amount of impurities present in the metal after liquefaction, right? So when you are solidifying the metal, see, suppose when you solidifying the metal, there will be places where there will be impurities. Then what will happen? These are already in solid state, right? So then from making this as center, the liquid particles will solidify. Okay, making this as the center, the liquid particles will solidify. Making this as the center, the solidification will start. So from here solidification will start, right? So from here also solidification will start. When you started solidifying, from these points solidification will start. So now if you take, suppose there is one more point here, then solidification will also start from this point. But when you come here, there will be colonies formed by this solidification region, right? So every impurity particle will form a colony. So this is one colony, this is one colony, and this will form another colony. Okay. So this will be another colony. So these things are boundaries, right? So these are known as grain boundaries. See, means it is like the impurities which are present, that are like nucleus, and around the matter will present. Okay, and similarly the impurity, another impurity will be another nucleus, and around matter will present. So this is around one nucleus and around matter will present. This is one nucleus, around matter will present. But here there will be boundaries. Okay. Similarly, so there will be boundary. So this, suppose if there is no here over here, so there will be boundary over here. Suppose there is something particles like this, then there will be boundary created by that. So these are known as grain boundaries. Do you understand? Right? This is about grain boundary. Means first we extract the ore, from that we extract the metal, then we will liquefy. After liquefaction, we will remove the impurities through metallurgical process. After removing the impurities, we will solidify. But after removing the impurities, there will be some amount of impurities, because we can't remove 100% impurities from the metal, right? So we may remove, but that will make costly. The process that will make the process costly. So we will remove most of the impurities, but there will be certain impurities present in the body. So making those impurities as the center, the solidification will start. So they will form some type of colonies. So each colony will be separate. So when they clash, then creates a boundary that is known as grain boundaries. Okay. So this is about grain boundaries. And maximum shear and tensile stress is maximum tensile stress will occur when theta is equals to 0. Maximum shear will occur when theta is equals to 45. And about Hooke's law, sigma is equals to E into epsilon for certain limit of stress. So that will be the stress strain diagram in that region will be linear. So these are three preliminaries which are required to understand stress strain diagram effectively. So with this we end today's lecture. In next lecture we are going to discuss next concepts on the stress strain diagram. Thank you.